2. Okay, it's 2 terms. Normally, what are you going to check for first? GCS. Okay? So, come and just sit anywhere, and then I'll figure out where to see this tomorrow. Okay, is there anything that goes into x squared and 1?
No.
No. Okay, so there's not a GCS. Okay? But we can still factor this, and I'm going to show you why in a second, but we're going to try to figure out the pattern first. Okay? Normally, if this was 3 terms, okay, it'd be x squared plus something x minus 1. Okay? Well, y'all, how many x's are actually in this problem?
1.
Whoa, this is not just an x, this is an x what?
Squared.
So how many x's are there? Squared.
Double.
Okay, yes, I'm with you, x squared. But is x squared and x the same thing?
No.
So what is the only number that can go here that's not going to change this? Not 1, because that means there's 1x. 0. Okay, so go put a 0 right there. So you're going to have x squared plus 0x minus 1. Okay? It's not changing. Okay? Now, how many terms is that right there, y'all?
3.
3. What do we do with 3 terms? Magic number, right? Okay, so make your little magic number chart. Alright, and what do we need to multiply to?
-1.
-1. Good. What number are we adding to?
0.
0. Alright, what are these? There's only 2 numbers that multiply to give you -1. What are they? 1 and -1. Well, y'all, what's 1 times negative? I mean, what's 1 plus -1?
0.
0. Can you shortcut this one? Yes, so you're going to go straight to x plus 1. And what's your other guy going to be?
X minus 1.
X minus 1. Good. Alright? Let's look at this second one. Okay, so I'm going to, is there a GCF? No, so I'm going to expand it to x squared plus how many x's? 0x minus 16. Alright, that's 3 terms. What do you do with 3 terms? Magic number. Okay, so set up your magic number. Alright, what are we multiplying to? -16, and what are we adding to?
16. 0.
What are the, there's only 2 numbers that multiply to give you -16.
16 and -16.
Actually, I lied. There's more than 2 numbers. What multiplies to give you -16, but adds to give you 0? Not close. -4 and +4. If you multiply those together, don't you get -16?
Mm-hmm.
And if I add them, I get 0. Can I shortcut this one?
Yes.
So we're going to have x minus 4. And what's your other guy going to be?
X plus 4.
X plus 4. Alright? Okay, just take a second to look at your original problem and look at your answer. Okay? Just marinate on that for a second. And we're going to go to our next one. Okay? So, is there a GCF? Does anything go into 4 and 25?
Yes.
What?
No.
Does 5 go into 4 though?
No.
Does 4 go into 25? No. Okay, so let's expand this. We're going to make this x squared, 4x squared plus how many x's?
0.
0x minus 25. Alright, how many terms is this now? 3, so set up your chart. Alright, what are we multiplying to? Not quite. What do you have to do? It's not, I'm not multiplying to a -25. Okay, somebody besides Taylor, where'd she get -100 from?
-4 times 25.
Okay, good. So -100 is what we have to multiply to. What do we have to add to?
0.
0. All right. What multiplies to -100 but adds to 0?
No.
Okay, but 100 times 100 is not 100.
No, it's -10 and negative.
-10 and
Positive.
positive 10. All right. You got to be careful on this one though, because you can't what?
Go straight to your answer.
I can't shortcut it. All right. So listen, you don't have to write down this work. I'm gonna do it for you, and I want to see if you can see a pattern. Okay. What's the GCF between 4 and 10?
2.
2, and they both have what?
X.
So 2x, this would become 2x minus 5. Okay? What's the GCF between 10 and 25?
5.
5, this is going to become
2x and
minus
minus
5.
5.
So I'm going to have 2x plus 5 and 2x minus 5. Alright, so I do want you to write down the answer. That this becomes 2x minus 5 and 2x plus 5. So, what I want you to see, I'm not going to tell you, okay? Look at your answers. Alright, what do all three of these answers have in common?
One of them might be negative and one of them positive.
One's negative and one's positive, but is everything else the same about them?
Yes.
Okay? Now, I want you to look at your original problem and your answer. Okay? Take a second, don't say anything out loud. Look at your original problem and your answer. So I started with x squared minus 1, and I got x plus 1 and x minus 1. Then I got x squared minus 16, and that became x minus 4, x plus 4. Then I had 4x squared minus 25, and that became 2x plus 5 and 2x minus 5. So, without doing any work, in your group, not out loud for the whole world to hear, I want you to take a guess of what you think this answer is going to be right here without doing any work. See if you can find a pattern to figure out what's going to go. What is 9x squared minus 16 going to become? Don't yell it out. Just talk about it. Before we talk about the answer, okay? I'm going to give you 4 numbers up here, and I want you to tell me which one doesn't belong.
It doesn't belong.
You don't even. I Okay, which one does not belong?
10.
10.
Why?
Because of 16 or the other number that goes.
Wait, what?
9 or 16 don't go into 10.
9 or 16 don't go into 10. Where are you getting 9 from? I don't see a 9.
No, I'm talking about on the paper.
But 9 doesn't go into 25.
Right, but
What does 9 got to do with that? I don't know where 9 came from. Why? Which one? What number does not belong?
wait, so it's one of those up there, right?
No, neither. This has nothing to do with the problem we just did.
Oh,
I'm asking, out of these 4 numbers, 3 of them all have something in common that one of them does not.
oh.
Wait, 10 don't.
Okay, I'm with you. 25 is not even. Yeah, that is one reason, okay? But in what I'm trying to do, I'm going to tell you 10 doesn't belong in my head. And I want you to figure out why does 10 not belong.
Because
All 3 of those have something in common that 10 does not.
Oh, because 10 is because everything over 10 is over 10. No, you see it, look.
10 is the
25
smallest? Are you
over
saying 10 is the smallest?
16.
yes.
Okay, sure. But that's not why I'm saying 10 is not in common.
Because
What do you mean it's not a fact?
No, 16 times 4 is 4.
What times 4 is 64?
16.
Okay, 16, yeah, but how does that relate to 25?
No, 4 times 4 is 16.
All right, hold on.
4
But
times
4
5
times 4 is what?
16 and 4 times 5 is 20.
4 times 5 is
No,
20.
5 times 5 is
oh, it's all
25
and
and 8 times 8 is 64.
All of these, what do you call these numbers when you multiply it by itself and you get a number? Perfect.
Number.
No, perfect squares. All of these are perfect squares, which means you can take the square root of it, okay? Y'all, what is the square root of 16?
4.
4, because 4 times 4 gives you
16.
16. What's the square root of 25?
5.
5, because 5 times 5 gives you.
25.
What's the square root of 64?
8.
8, okay? What's the square root of 100?
10.
10. All of these are perfect squares. Is there a number, if I take the square root of 10, am I going to get a whole number answer for this?
No.
No, so 10 is not a perfect
Number.
square. So,
Well,
what is this 9x squared minus 16 going to become?
3.
3.
3 what?
8.
Minus
4.
and
3x plus 4.
Alright, so let's talk about how that happens. Okay?
It was perfect square.
Is 9 a perfect square?
Yes.
And what's the square root of 9?
3.
3. Is 16 a perfect square?
Yes.
What's the square root of 16?
4.
4, okay? You see where those came from?
Yes.
Now, hold up. These type of problems are called difference of squares. Do we understand where the squares is coming from?
Yes.
That's why you zoomed in.
What is difference? What does that mean?
Opposite.
No, that would be difference. What does difference mean in that?
The
Subtract. Are all of these problems subtraction problems?
Yes.
Yes. So to be able to do difference of squares, it has to be a subtraction problem, and they all have to be perfect. What?
Perfect squares.
Perfect squares. Okay. So if it's subtraction and they're both perfect squares, you don't have to do all this work. You can go straight to your answer. So, for example, go look at number 1. You got x squared minus 81. Can you do difference of squares with this? Is it subtraction?
Yes.
Are they both perfect squares?
Yes.
What is this going to become?
X minus 81 and x plus 81.
X minus 9 and x plus 9.
Oh yeah, 9.
Okay, because you have to take the square root of
Yeah.
81. Alright? You got x squared minus 100. Can you do different squares on this?
Yes.
Alright, what's that going to become?
X minus 10 and x plus 10.
X minus 10 and x plus 10. Good. Alright? Talk to me about 3.
It's gonna become 2x equals 4.
2x equals 4?
No, 2x minus 4 and
2x plus 4 and 2x
minus 4.
minus 4. Alright? Do we get the gist? Kind of.
Yes.
Alright, in your group, I want you to try 4 and 5. Deja, what's that 4x squared minus 9 going to become? Take a guess. What's that 4 going to become? A 2? A 2 what? Okay, not squared. Do I need this squared anymore?
No.
No. Okay, what's that 9 going to become?
3.
So 2x minus 3. What else?
2x plus 3.
2x plus 3. Good. Alright, 5. Okay, what'd you get on 5?
I got 5
Plus 1? Everybody okay with that?
Yes.
Alright. I'm calling Taylor out. She fell for my trick on number 6. She said 5x plus 10 and 5x minus 10. Is that right?
No.
What kind of problem is number 6?
Addition.
Addition. Circle that plus sign.
Oh.
Can you do difference if it's an addition sign?
No.
No. So, you can actually still factor this problem. What do you always check for first?
GCF.
GCF. What goes into 25 and 100?
5.
Something
5.
bigger.
10.
10.
25. Doesn't 25 go into 100?
Yes,
So
25.
I'm going to take out a 25, and I'm going to have x squared plus. Alright? 7. Can you do difference of squares on 7? Yeah? Is it subtraction?
Yes.
Are they both perfect squares?
No. Well, yes.
Is 3 a perfect square?
No.
Is 28 a perfect square?
No.
So I can't do difference of squares. What else should I check for? Check for a
CF.
GCF. Is there a number that goes into 3 and 28?
Yes.
Does 2 go into 3?
No, it's
3
one.
goes into
Does 3 go into 28?
Yep.
Really? What's 28 divided by 3?
Point
Not a
0
decimal.
something something.
It's a decimal, so does 3 go into 28?
No.
Alright, so can you factor this one?
Oh.
So you're just going to leave them the same. Alright, let's talk about 8. Can you do difference of squares on 8?
Uh-huh.
Are they both perfect squares?
No.
Is 2 a perfect square?
No.
Yes.
What times what gives you 2?
Nothing.
So it's a perfect.
1 times 1.
What's 1 times 1?
No, 1 times 1 is 1.
It's 1, so it's 2 a perfect square.
No.
Great job.
So I can't do difference of squares.
You're
So now I'm going to check for what?
GCF.
What goes into 2 and 128? No, there is a number.
2.
2, and they both have a what, y'all?
X.
X. Okay, so if I have 2x squared, and I take out a 2x, what's that just going to become?
1 x.
X, good.
Minus 6. 4.
Alright, pause. Can I keep going?
Yes. No, you can't,
Why not?
because we don't want
Can I keep, hey y'all, can I do difference of squares with this right here?
No.
No.
Why not?
Yes, no, you can't, because the x to the second has no x.
Alright, pause. Hey, whoa. What does the x plus 64 and x minus 64?
Yes. No.
What would the 64 become?
8.
An 8. Okay? So x plus 8, x minus 8?
Mm-hmm.
No.
No, 2 parentheses x plus 8.
Okay, you can't forget about your 2x, you're right.
8.
Are both of these perfect squares?
No.
No. No.
That's a perfect square, right?
Yes.
It's subtraction, which is good. And is that a perfect square?
No.
No, so can you keep going?
No.
If this, whoa, if that was a x what? If this x was what right here, could you keep going? If that x was squared, you could keep going, but is this x squared?
No.
No. Alright, number 9. Can I do difference of squares?
Yes.
Is 36 a perfect square?
Yes.
Is x squared a perfect square?
Yes.
Is it subtraction?
Yes.
Is 144 a perfect square?
Yes.
What's that going to become?
6x minus 12.
Awesome. Good job. Alright, we got 3 more, then we'll be done with notes. Alright, 10. Any guesses? Actually, I want you to do 10 in your group. Don't yell.
Yes.
Alright, Landon, what'd you get on 10?
11x minus 10x.
11x minus 10x?
No, 11.
Hold up. That's all you got?
Oh, 11 minus 10x to the second.
11 minus 10x to the second? Well, I didn't write that right.
Wait.
It's 11 minus 10.
Alright, hold up, pause. Let's just stop with this right here. What do you like about this?
Nothing.
Nothing, the whole thing, I'll give you no credit. I would give you credit. Yeah, what do I like? Okay, the 11. Where is this 11 coming from?
The 121.
121. Hold up, pause. What else do I like?
The negative 10x.
The 10x. Okay, where's that 10x coming from?
The negative 100 squared.
Okay, what do I not need?
The x.
I don't need this x because did that 121 have an x?
Oh, got it.
Alright, so we good?
Yes.
No.
No, you gotta do 11 plus 10x.
Good. 11 plus 10x. Alright, what is funky about number 11?
It got a lot of variables.
Alright, it's got variables and different exponents. So let's just go through it. Is 1 a perfect square?
Nope.
Yeah. You just said it was.
No, I didn't. I said 2 was not. What's the square root of 1?
1.
1. Is that 1 times 1, 1? Is it subtraction? Is 81 a perfect square? What's the part we feel iffy about? The x to the 6, right? Because what is this y to the second going to become?
Y.
Just a y, which is technically a y to the what?
First.
First. Alright, so you can take the square root of x to the 6. Any guesses of what it's going to become? It is going to become x to the
Third.
third. All you do is divide it by
2.
not 1, but 2, okay? So what is this 1 going to become? 1 minus 9x to the
Third. And Y.
y to the first if you want. And what's the other one going to be?
1 plus 9x to the third.
Good. Alright, so, knowing this, try 12. Go. Who wants to answer it? Raise your hand. Oh, and I go for it.
1x to the second. I mean y to the second minus x to the fifth.
Okay?
And y to the second plus x to the fifth.
Everybody okay with that?
Yo.
Alright, now, one little thing I want you to be aware of. Could you do difference of squares on this right here?
No.
Yes.
No.
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 What's the problem with this problem?
3.
3. Can you divide 3 by 2? No,
No.
so you would just leave it the way it is. How do we feel about this?
Good.
Decent?
Yes.
Okay? what I would like you to do now